Now let's do a little work with tables of equivalent ratios. So a class is going to make some paper mache, and they're going to use both flour and water. And for every 2 cups of water, the teacher is needing to mix in 3 cups of flour to make this paper mache. So our ratio looks like this. Water to flour would be 2 cups to 3 cups. The actual meaning of the ratio is for every 2 cups poured in of water, they need to pour in 3 cups of flour. Or said differently, every time we have a set of 2 cups of water, we need to have a set of 3 cups of flour. But why do you think we use the words for every 2 cups of water, there are 3 cups of flour? That's a big hint that probably this is going to happen more than one time. They're not only going to use 2 cups of water alone, they'll probably need more. And for every 2 cups of water, they will need 3 cups of flour. But why would someone do it more than once? When we use recipes for cooking or things like even paper mache and crafts, usually we need to have more batches than just one, depending on the size of people that we are catering to. So then, let's list some of the possible recipes for this exact mixture in a table. Okay, cups of water, cups of flour. We know that for every 2 cups of water, there are 3 cups of flour, so we can put that in. But what if we had another batch? If we needed to make more, we could double it and end up with 4 cups of water and 6 cups of flour. But what if we needed another batch? We could triple the recipe and end up with 6 cups of water and 9 cups of flour. Or we could quadruple the recipe, 8 cups of water and 12 cups of flour. Or we could have 5 times as much as the recipe if we needed, using 10 cups of water and 15 cups of flour. Check this out. What's the ratio on our 2 cups of water and 3 cups of flour? 2/3. What about the ratio of 4 cups of water to 6 cups of flour? Isn't that 4 to 6? Well, yes, but it can be simplified. An equivalent ratio of 4 to 6 is 2 to 3. And the same can be said for 6 to 9. We can make groups of 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So we have 2 to 3 again. And wouldn't you know, 8 to 12 has the same equivalent ratio, 2 to 3, and 10 to 15 is also equivalent to 2 to 3. Why? Well, let's think. 10 in groups of 5 would be 2. 15 in groups of 5 would be 3. Yep, they're equivalent. Alright, Javier stays home and he's a web page designer. He works on his computer and he makes a certain amount of money per web page that he makes. In fact, he earns $700 for every 3 pages of web content that he designs. So let's have some fun and make a table and see just how much money Javier could make. Okay, we know that there is a number of pages he must make and a number of amount of money he can earn from those pages. So let's make those 2 columns. And we are given the very initial one of 3 pages he designs, he earns $700. But what if he did twice that much? What if he made 6 pages of web content? Well, that would double his amount of money, and so he would earn $1,400. But what if he did 3 times as much? Then he'd be making 9 pages, earning $2,100. What if he did 4 times as many? 4 times as many pages would be 12 pages of web content, and he'd be earning $2,800. 5 times as many? 15 pages designed, $3,500 earned. 6 times as much? 18 pages designed, $4,200. And just for fun, what if he did 7 times as much? Then he would be making 21 pages of web content and earning $4,900. Okay, Javier has his eyes on a car that he wants to buy. It costs $4,200. How many web pages of content will he have to design in order to earn enough to buy that car? Let's see, his car costs $4,200, so he would need to make $4,200 at least, and look, there it is on our table. So how many pages of web content does he need to make? Yes, Javier needs to build 18 web pages in order to pay for that $4,200 car. Okay, there's this plant spray that helps the plants to grow. It's made by mixing a certain amount of cornmeal and water. With just that data alone, we can make a table, cups of cornmeal to gallons of water. And we're told that for every 2 cups of cornmeal, you need to mix in 9 gallons of water for this spray. If we doubled that recipe, we'd need to use 4 cups of cornmeal and 18 gallons of water. What if we wanted to make 3 times as much? Then we'd need 6 cups of cornmeal and 27 gallons of water. 4 times as much would be 8 cups of cornmeal and 36 gallons of water. And if we wanted to make 5 times as much as this spray, we'd need to make sure we have 10 cups of cornmeal and 45 gallons of water. So, if we are asked how many cups of cornmeal should be added to 45 gallons of water, we just look at our table. You tell me, how many cups of cornmeal do we need if we have 45 gallons of water? Yeah, look down at the bottom. There's our 45 gallons of water. How many cups do we need of cornmeal? Look across to the left. We need 10 cups of cornmeal. Okay, this guy Paul, he only has 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice, this plant spray, as he can? Okay, he only has 8 cups of cornmeal. Let's look down. Oh yeah, there's 8 cups of cornmeal. If he wants to make as much spray as he possibly can, he should add 36 gallons of water. What can we say about the values of the ratios in this table? Looking at these ratios, we know that each one was developed by simply doubling or tripling or on the original ratio. So all of these ratios and values are equivalent. So James wants to have an aquarium of goldfish. He learns that fully grown goldfish are about 12 inches. And that for every 1 inch of goldfish in an aquarium, you need to have 1 gallon of water. So then what's the ratio of recommended gallons of water per fully grown goldfish in a tank? Well, we know we're dealing with 2 things, numbers of fish and gallons of water. So we can start our table. If James has 1 fully grown goldfish, then it'll be 12 inches long, because that's how long fully grown goldfish are. But we need 1 gallon for every inch, and since it's 12 inches long, it needs 12 gallons of water. And if we kept adding goldfish to the aquarium, like 2 goldfish, then we would need 12 more gallons of water, because there will be 12 more inches of goldfish. And then if we added another goldfish, 3 total, we would need 36 gallons of water, and so on and so on. And so what size tank, gallons of water, would James need to have if he wanted to have 5 fully grown goldfish? Looking at our table, 5 goldfish. They're at the bottom. How much gallons of water? 60. James needs a tank that would hold at least 60 gallons of water in order to have those 5 fully grown goldfish. How many fish could James fit into a 40-gallon tank? Let's see, 40 gallon. I don't see the number 40 on here, but 40-gallon tank would hold 36 gallons of water. It wouldn't hold 48 gallons of water. How many fish does a 36-gallon water tank hold? That's right. In a 40-gallon tank, you could have at least 3 adult, fully grown goldfish. Take a look at the values of these ratios in our table. What could we say about them? Once again, if the ratio is 1 to 12, and we simply double it or triple it to get the next, then we know that each of these are equivalent. They have equal value. The values of these ratios are equivalent. Okay, so what have we learned about using tables with equivalent ratios? Well, let me ask a question. When creating a ratio table, what does each pair of values represent? Here's a ratio table. What does each pair of ratios or values represent? So when we use a ratio table, we essentially are using the same value for every single ratio. These are all equivalent ratios because they have the same value. It's just that we're doubling or tripling or however many times we want to of a certain ratio. Equivalent ratios have the same value, and we can see that in the table.